Archimedes' principle is the following. If an object partially or is fully submerged in a fluid, it will experience a buoyant force. Period. I right now am experiencing a buoyant force. However, my weight exceeds the buoyant force, so I am still sitting on the table. I am not floating. Okay? So everything that displaces a fluid experiences a buoyant force. The question is that force greater than its weight? So think of the beach ball. Has a mass m. Let's say it's in fresh water. Oh wait, kilograms per meter cubed. Do you agree? This has a volume of the beach ball. And let's say it's filled with, what would you like to fill it with? Something less dense than water.
Air.
With what? Helium. Does anybody know the density of helium?
Neon.
Google! Google!
Density. .214 grams per centimeter cubed.
Uh-oh.
I know, you need it in kilograms.
Oh my gosh, someone's got to make the conversion. Thanks.
So why did it have Google still in?
You make it the salt. What's that? The pressure.
.1785 kilogram per cubic meter.
Yay, 1785 kilograms per meter cubed. There, so we have a beach ball that's filled with helium. Not just air, but helium. What would air be? Air is 1.29 or so kilograms per meter cubed. Okay. Either way, they're both less dense than fresh water, correct? So let's look at the forces on the beach ball. mg down. All right, so are we going to ignore the mass of the helium? Let's do that. Let's just say we have the mass of the ball is the only thing that's really heavy. Okay, so yes, I have the weight of the beach ball times g down, and I have a buoyant force up. How do I get that? Now, here's a question. How many of you have ever pushed a beach ball down underwater? This is almost everybody.
What was wrong with the picture?
And if you let go, what happens? It shoots up. But what if it didn't? What if it actually just floated? What would that say about the beach ball?
Density.
It's kind of heavy. I mean, it's got a lot of mass to it, right? Okay. But our beach ball, we all know from experience, will shoot upward. And when it rapidly moves upward, what is it doing? Accelerating. Okay, so the net force equals m beach ball times A. I'll put beach ball. Do you see how that happens? If the net forces are not equal to 0, that means it's accelerating. If I take a piece of lead and I hold it underwater and I let go, is it accelerating? Yes, it is, but downward. Okay? Because the weight exceeds the buoyant force, so it accelerates downward. If they're equal, that means the buoyant force equals the weight and it floats. So let's finish this problem, then we'll do one that floats. Okay. So buoyant force is rho, in this problem, rho of the fresh water times the volume of the beach ball times g. displaced fluid times the volume of the object in the fluid times G is the upward force on the beach ball. Minus the mass of just the skin of the beach ball times G equals the mass of the beach ball times A. We could, if we wanted to, guys, include the mass of the helium, but it's probably not a lot to it. Does that make sense? So I could actually find, if I knew these two masses, I could find how quickly this thing will accelerate.
Can we ignore the mass of the beach ball?
It's in there, MBB.
Can we ignore it?
Can you ignore it? No. Don't.
Beach balls
I
have
don't know.
mass.
So now let's talk about something that would float. I don't know, what would you like to have float?
Polar bear.
A what?
Polar bear.
Polar bear? Should we do a problem? Let's do a problem.